Today, we're going to investigate matter, and we're going to learn about properties of matter. Properties are kind of like how you describe matter, and it's going to be kind of fun because we got a lot to do, but I'm telling you, I'm going to warn you right now. I've been having a little bit of trouble with my my computer. See, I was trying to find out that, I know that math is the language of science, and so I thought, you know what? Maybe we need to practice learning a little bit more about measurement and math. And so today's lesson is the super duper all-purpose measuring device. And my computer keeps kind of interrupting me, so I hope that we get through this. So let's start by taking a look at your worksheet. Your worksheet looks like this: matter exploration, okay? And on this worksheet, go ahead and put your name on it. I'll put mine right over here, and the date. I've used the word matter several times, matter. So, matter is the stuff that things are made of in the universe, in the world. Matter. Like, my ink pen is made of matter. My phone, this mouse is made of matter. Even my head's made of matter. The air we breathe is made of matter. Matter is all around us. Matter is the stuff that things are made of. And scientists like to describe matter and its properties, and you're going to be a scientist today describing matter. So, what is matter? Well, it's two things. Matter, go ahead and write this at the top of your worksheet. Matter, two things about matter. It takes up space. Matter takes up space. Do you understand that? That matter takes up space? Well, what I mean by that is that, for example, this ink pen takes up space. That means I can't put my finger because it's already being taken up by, that space has already been taken up by that ink pen. So matter takes up space. And also, the second thing about matter, matter has mass. Mass. Mass means, has mass, it has stuff in it. Takes up space and has mass. You should write that. Yeah. Takes up space. So if I say, repeat after me, matter takes up space and has mass. That reminds us, let's do that again. Repeat after me. Matter takes up space and has mass. You see, those remind me of some pictures of some people that I know. Check this out. All matter takes up space. And here's a picture of Vanna White. She was always holding up her hands and taking up space. So Vanna White takes up space. And also, Arnold Schwarzenegger has mass. Very strong, has mass. So we have takes up space and has mass. Pretty cool. So when I go like this, takes up space, has mass. All matter takes up space and has mass. And today, we're going to investigate some properties, and I'm going to try to look at some measuring devices. There's a lot of measuring devices that we can use. So let's take a look at our worksheet. And at the bottom of this worksheet, I have a little chart that I've made, and we're going to work on this together. And this chart has to do with properties of matter. Properties. It's like ways that we can describe different parts of matter. As long as my computer doesn't mess me up. Oh, there's that computer causing me lots of trouble. Computer, we're learning about matter. Thank you. Yeah, we don't need you to comply, computer. I'll need your help later. Please sign off. Okay. Sorry about that, guys. This computer's been bothering me a lot. All right, so when we have property of matter, we have instrument. Let's write the word science instrument. Science instrument right here, okay? Science instrument. Another name for that is tool. Tool. Science instrument or tool. Now we're going to make a drawing, and some science. We're going to talk about some science units. Those are units that scientists like to use, and you're going to like to use them too. At least I hope so. So we have here length, mass, volume, and temperature. Let's take a look at length first, okay? Length is something, back to my ink pen. I could tell the length of my pen. Now, okay, I'm going to use something called a ruler. All right? And it looks like this. I'm going to make a drawing of it. Go ahead, write ruler. It's what we use to measure length. There's a drawing of it, and here's what it looks like in the real deal. And it opens up, and opens up, and opens up. In fact, it's pretty long. This is a ruler, a very long ruler for measuring length. Measuring length. So if I go like this, that means length. In fact, if I come and see you, if I go like this, you know that's length. Ready? Here we go. Everybody do it with me. Length. We use a ruler, and our units are cm, which stands for centimeter. Centimeter. Now, these are small science units, a cm. So there we go. Let me give you a second here until the computer interrupts me for you to get that down. Length. We use a ruler. We measure in centimeters. Right, computer? That's really? Is that right, computer?
Enterprise here. Scans indicate no intelligent life on this planet.
What do you mean no intelligent life? How rude. I tell you, that computer has been acting up all day long. Okay, length, property of matter. Use a ruler. The units are centimeters. Our next one is mass. Mass, how much stuff is in it? And I have a tool here we use. This tool looks like this. This is my balance scale. My balance scale. Okay, up and down, this side, this side. So a balance scale is a tool. Here's my symbol for it. Everybody do this. Balance scale is a tool for measuring mass. Write this with me. Mass. We're going to use a balance scale. And it looks like this. It looks like this. It has a little thing right here, and it sits on something like this. And what we could do is we can put, like if I put an apple right here, okay, and then over here I could put some masses, and as long as they are balanced out, that's my balance scale. Balance, length, balance, and here's the science units we're going to use today. G for gram. Cool. All right, so we've got two already. We have length, we use a ruler, we measure in centigrams. We have a balance scale, we measure mass in grams. Got that? Mass, balance scale, grams. Okay. Check it out. Wonder if the computer, I hope that computer can help me with this, okay? Because now I have to use this for this and that. So, yes, computer? Oh, I'm going to do volume next. Yes, volume is next. Please don't cause me trouble. I know you've been acting up. Strange sounds are coming from you. Please, no, not now. All right. I'm telling you, I've been hearing some strange sounds out of this computer. It likes these different things, but I'll tell you, volume, that's a new word. Now, my daughter went to get her hair done, and she came back and said, look, they volumized my hair. They made my hair look bigger. So I'm thinking, volume, like a V. So put your hands like this. Volume. It means to how much space it takes up. Volume. Got it? It's not length. It's not mass. It's volume. And what do we use for that? Oh, I know what we use. We use something that looks like this. It's my graduated cylinder. My graduate cylinder. Here we go. Check it out. So it's a graduate cylinder. That's the weird name for it. Graduate, which means it has markings on it. Cylinder, which means the shape. A graduate cylinder. Very good. Copy that down. And here's what it looks like. Okay, it comes down like this and has some marks on it. Graduate cylinder. Now, like if it's too big to fit into that, we might try something like this, like a beaker that's even bigger with a bigger mouth, but it has markings on the side of it. But boy, I tell you, there's something weird. The computer keeps coming up and I keep hearing the strange sounds.
There is nothing wrong with your television. Do not attempt to adjust the picture.
I'm worried about it.
We are now controlling the transmission. We control the horizontal.
No, computer, don't control.
We can deluge you with 1,000
No,
channels.
look, I just was wondering why I keep seeing something like L times W times H. I don't know what that means. Computer, please don't cause me trouble about this, if you don't mind. Okay, never mind. All right, computer.
There is nothing.
Yeah, I know, nothing wrong. All right, what units are we going to use? We use centimeters for length, grams for mass. I know. Here we go. ML, which stands for milliliter. Milli, which is divided by 1,000, liter. A milliliter, an ml, milliliter. All right, so we have 3 of these so far. We have length, use a ruler, measure in centimeters. Mass, use a balance scale, measure in grams. Volume, you should do these with me. Volume, use a graduate cylinder, measure in milliliters. Very cool. And there's other things like measuring time. I might use my watch, or I might use a stopwatch. Okay? So you guys have 5 seconds to finish these notes. Oh, time's up. Stop, reset. So properties, things that we can measure. In this last one, temperature. What do we use? What's my symbol going to be for temperature? I'm thinking, it's kind of hot in here. Oh, wait a minute. I can feel the heat of my head. So this will be my symbol for temperature. Yes, everybody do this. Ready? So temperature. We use something called a heat meter or a thermometer, thermometer, yes, a thermometer. Go ahead and write thermometer. Got that? Okay. And let's see. Oh, there's that computer going again. Sorry, computer. Sorry. He wants us to draw quicker. Okay. It looks like this. All right. So it's like a round glass bulb and a tube. And it's usually red. If it's red, it's a good thermometer to use. Boys and girls, if you find a thermometer that is silver, you really shouldn't use that. That has mercury in it. Red is a liquid that won't hurt you as bad as the mercury one. So as long as it's red, it's good. And I see mine right here. Look at this. Check it out. There's my thermometer with that. And I might be able to put this around and see if I can make it go up just by the heat of my hand. And is it going up? Let's see. I don't know. Is it going up? Up, there it goes. But is it 80 or is it 25, 26? That's weird. Oh, a thermometer has 2 sides to it. One is degrees Fahrenheit and one is degrees Celsius. All right? Like today it was 76 degrees Fahrenheit, which is about 22 degrees Celsius. Huh. You heard the word I used. The unit is a degree. A degree. Okay, with a little dot right there. Degree. So, we have found length, mass, volume, and temperature. And I'm going to give you just a second. I'm going to see if you can remember them by my symbols. Check it out. Okay, what is this? What is this? And this? And this? So, we've talked about length, mass, volume, and temperature. These are all properties of matter, but I'm trying, computer, this is too much stuff. I wish we just had one thing that we could use. If we just had one, just one thing, computer, just one thing we could use. Let me check with the computer and see if there's just one thing that we can use here that that would work for us. And I hope this will work. Computer, transmission, power on. Yes? Detected human life form, okay. I'm trying to determine whether we can have one instrument that will do length and mass and volume and yeah, I know I'm part human. Yeah, I know, computer. Makes me so angry when that computer does that. But wait, there's something on my computer. There's something coming through the computer. Let's take a look at it. A strange cube. Look at this cube. Computer, I can take this cube off. Look, it just created a cube for me. Huh. So that is what I'm going to use. This cube right here. Well, you know, I put in there, I wanted a super duper, all-purpose measuring device. Let's write that down. And supposedly this is the super duper, all-purpose measuring. That beats out the ruler and the balance scale and graduated cylinder and come on, computer. All right, I ask for a, boys and girls, write this with me. I ask for a super duper, all-purpose measuring device. Come on. All I wanted was one thing that I could use. Dun, 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 dun. A super duper, all-purpose measuring device. That's all I wanted was, you know, super duper, all-purpose measuring device. And this is what you send me? Are you kidding me? Go ahead and write this down, super duper all-purpose measuring device, and I might as well draw a picture of that, and here we go. It looks like this. It's like that, and like that. Can you draw that? Okay, got it. Super duper all-purpose measuring device. I got to see this. All right. Oh, you know what? It is like a cube. Can you see that? It does have different sides to it, and they all seem to be the same length and the same size and the same shape. So I better do this. Help me here, watch. Do this with me. Here's my area, and this is 1 centimeter and by 1 centimeter and 1 centimeter, but let me draw a line back like this. You do this too. 1, 2, 3. Can you do that? Huh. And let's see. Draw a line here and straight down. Oh, there we go. There's my cube. Now it looks like a super duper all-purpose measuring device. You know, measuring devices have been around for a long time, and it depends on when and where they were different. Check it out. Here are some that are from ancient Egypt, from ancient Greece, and water clocks, and sundials, and astrolabes, and even Stonehenge. These are all measuring devices to measure different things, and we've had clocks and sundials and sundials and systems. So there have been lots of measuring devices all over the world at different times, and we use those to measure properties of matter. Cool stuff. Cool stuff. So maybe this super duper all-purpose measuring device is something in the future. I don't know, but I know one thing. The computer keeps making a bunch of these. So this is equal to 1 centimeter cube. Huh. Go ahead and write that. Huh. It's also equal to, each side is 1 centimeter in length. That's cool. So I got a centimeter cube. Huh. And it's 1 centimeter in length. Well, you know what? I'll tell you. If that computer makes more of these, and let me check it, then we'll use those. Let's put it to a test, shall we? Computer, have you made more? Computers made more. They just keep making them. Thank you, computer. Yes, I know. Can you explain why it's a super duper all-purpose measuring device? Unable to comply. I'll tell you, every time I ask the computer to explain how it's a super duper all-purpose measuring device, it says unable to comply. You're going to have to help me figure this out. Okay. I have blocks of wood. Everybody has a block of wood, right? And I have my block of wood right here. And this block of wood is made of matter. You know why I know it's made of matter? Ha! It takes up space and has mass. Yeah, it takes up space and has mass. I'm going to set mine on my piece of paper. You do the same. And we'll be all right as long as this music doesn't, strange music doesn't start again. Okay, so I got my music computer. We don't need that, thank you. Wow. Okay, I'm gonna put my block of wood right there, okay? And I'm gonna trace it. Go ahead and trace yours. I'm gonna trace mine carefully. That's how long it is, and here's how wide it is, and how long it is, and I'm gonna make it, oh, look at that. Okay, I lift it up. Ta-da! Nice job. Okay. You do the same thing. What I'm going to do is I've written down the length. This is the length, how long it is, and I'm going to measure these out. And it looks like there's 5 of them. 1, 2, 3, 4, 5. So the length of my block is 5 cubes. And I know that 5 cubes equals 5 centimeters. Go ahead and measure yours. Well, I'm starting to get those strange sounds again. Okay, cube, centimeter cube, you're okay for length, but what about width? What about how wide something is? And wide on mine goes this way. So computer, let's see. Let's see if you can measure how wide something is going this way. W for width. How wide is it? I'm going to lay these on here and count them. 1, 2, 3. Ha! The width, I could use my super duper all-purpose measuring device, and I am 3 cubes wide. 3 cubes wide. And so I know that 3 cubes, okay, 3 cubes equals 3 centimeters. So computer, do you think that who's so smart now? The students working with me, or you and your space music? What do you think, computer? Can you answer that question? Unable to comply. Yeah, I think you're you're unable to comply. Don't worry, we'll figure this out. Okay, so we've used the centimeter cube to find length and width. It looks like this. And so next is height. Height. Height is how tall something is. So, let me see. Let me use some cubes. 1, 2, 3. 3 cubes. That's how high mine is. 3 cubes. My height is 3 cubes, which equals 3 centimeter. Hey, this is getting kind of cool. Maybe these are super duper. Maybe these are super duper all-purpose measuring devices. But I'm going to need some more. No, I'm just going to need some more, computer. I'll tell you what, boys and girls, go ahead and find out the height of yours. But before you do that, how are we going to draw that? Oh, I got an idea. Just like we did on the cube, let's make a line like this. Ready? And a line like this that are parallel, those two lines. And one more like this. 1, 2, 3. And let's just connect them. And this is my height. My height. And my height, my h, is equal to 3 cubes. Cool. All right, go ahead. Try yours. See how tall yours are. We have found the length, the width, and the height. Wait a minute. Length, width, and height. L, W, H. Where have I seen that somewhere before? L, W, oh, I know. Down here on volume. Length, W, and H. Okay, so you're telling me that volume can be equal to the length times the width times the height? Well, you mean volume could be equal to my length is 5 times 3 times 3? If I can only do that math, there's got to be a better way. Computer, is there a better way? There is. The computer says there's a better way, and it's sending me that data via space right now. So let's check it out, shall we? This ought to be very, very interesting. Okay, show me. Computer, I need to see this, please. Where is it?
How can you visualize volume as building layers on top of a base? In this lesson, you will learn how to determine the volume of a prism by analyzing layers and counting cubes. First off, let's review what a cubic unit is. And each cubic unit has edge lengths of 1 unit and 1 unit only. Now, it doesn't matter what that unit is. So right here we have a cube with dimensions of 1 plip by 1 plip by 1 plip. A plip is a made-up unit to prove a point. If we take a plip times a plip times a plip, we will get a plip cubed, which we can also call 1 cubic plip. So you might have a cubic inch, a cubic foot, a cubic meter. Cubic units come in all different sizes, which enables us to measure objects of all different volumes. Now, volume is the number of cubic units needed to fill the space inside a three-dimensional figure. Every 3D figure has volume. So we could measure the volume of this house in cubic units. We could measure the volume of this dictionary. We could measure the volume of a tent. And we could measure the volume of a carton of milk. We would use different cubic units for differently sized objects. So let's take a look at a 3D solid. Right here we have a rectangular prism, and let's see if we can figure out its volume. We're going to take a very interesting approach today, and that approach is we're going to look at how many layers are in this rectangular prism. So when I look at this prism, I see 1 layer on the bottom, 1 layer on the top. And I say to myself, if I could figure out how many cubes were in each layer, I might be able to find out the volume of this solid. So let's analyze just 1 layer. When I look at it, I see that it is made up of 1, 2, 3, 4, 5, 6 cubic inches. Interesting information. So I know that 1 layer is 6 cubic inches, but I know that there were 2 layers in that prism. So I can say to myself, 6 cubic inches plus 6 cubic inches, well, that will get me a volume of 12 cubic inches. Well, what if I reorient the prism? Let's check and see if this approach where we break the prism into layers, let's see if it still works. So this prism has not 2 layers, but it has 1, 2, and 3 layers. And each layer is made up of not quite as many cubes. Let's go ahead and analyze one layer. If I look at this layer, I can see that it is made up of 1, 2, 3, 4 cubic inches. I'm going to use that same approach. 4 cubic inches on the bottom, 4 cubic inches in the middle, plus 4 cubic inches in that top layer means that, unsurprisingly, the volume is exactly the same. No matter which approach we choose, it is 12 cubic inches. In this lesson, you have learned how to determine the volume of a prism by analyzing layers and counting cubes.
Wow, that was amazing, computer. Thanks for sending that to me. So we were able to see that that volume can be using cubes. We can use cubes to figure it out.
There is nothing wrong with
Yeah,
your
I know.
television.
I'm not trying to take over. All right, so let's see. Let me get my block and let me get my cubes, and you might want to try this too. Let's see. I'm going to make a layer. My layer is going to be 5 by 3. So go ahead and start yours, and I'll start mine. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, that's only one. I got to make some more. One. Hey, computer, I'm going to need more super duper all-purpose measuring devices. Please send me more. Thank you, computer. Boys and girls, I hope the computer has sent some to your teacher that you can use. Okay, here's another row. And that is, let's see here. I've got this 1 row, 2 row, and let's see. Let's see. 3 rows. Look at that. Look, I got it. Look, I'm using my block. Look, I'm done. That's the volume. Oh, wait a minute. That's only 1 layer. I have to do, how high is, I have to do 3 layers. Go ahead. I'll do mine. You do yours. Very strange music coming from the computer. Sounds like somebody's lost in space as far as I can tell. Huh. If they were lost, I hope they're found. Now I've got my second layer. Am I done? No, I need 1 more layer. Well, you guys go ahead while I finish mine. Okay, so I'm almost done here. I got my 3rd row, and there's my last one. Oh, computer, I need a brown one. Thank you. Look at that. So, I bet you guys have a better job at this because your hands are smaller than mine. But here, look, I've made it 5 long, 3 wide, and 3 tall. Check it out. Look, mine is just like this. Cool, look at that. If I turn it around, you can see it. Okay, computer, what do you think about that? I've used these super duper all-purpose measuring devices, and I can now count them and find out how many cubes this is. And I'm going to count by 5s because these are nice 5s. Here's 5, 10, 15, up, 20, 25, 30, 35, 40, 41, 42, 43, 44, 45. 45, guess what, computer? The volume of my wooden block is 45 cubes, which means that it is 45. Oh, you know what? These are in cubes, so it's 45 centimeter cubes. And it is 45, if I use that, milliliters. It could be milliliters if it was water. Wow, this is a super duper all-purpose measuring device because that cube is also equal to 1 milliliter of volume, or 1 centimeter cubed with a little 3 right there like that. Just think, this one little thing does that. Thank you, computer. But will you tell me how to use it for mass? Will you tell me that? Unable to comply. Ah, I guess we're going to have to find the mass, find a way to use the mass with these super duper all-purpose measuring devices. Let me give you a second to get caught up here. One more property, and if we find this property, then I will agree that for matter, either length or mass or volume, the super duper all-purpose measuring device is the right tool. Okay, let's see here. I know that if I use a balance scale, if I use a balance scale, that's good for finding the mass of something. So I wonder if I could, I think I have it. I think I have a way that we can use the super duper all-purpose measuring device to find the mass of my wooden block. Here we go. If I put this on this side right here, it goes down. If I put it on this side, it goes down. I'll put it on this side, and I know that the computer said these are worth 1 gram of mass. So here we go, 1 gram, 2, nothing, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, nothing, 14, 15, 16, 17, it's not moving at all. 18, wait, 18, it moved. 19, 20, 21, it's starting to move. 22, 23, 24, it's almost level. 25, wow. These are super duper all-purpose measuring devices. It really worked. Mine balanced 25 super duper all-purpose measuring device, or centimeter cubes, and I know each one of those, the computer told me that each one of these is also equal to 1 gram. So, oh, you're not so smart, computer. We figured it out, 1 gram, and so I had 25 cubes, and that equals 25 grams. 25 grams of mass. Wow. I tell you, these are some super duper all-purpose measuring devices. These are pretty cool. Computer, what do you think about that? We solved it. We solved it. And you know what? This time I'm going to play some space music that is good. And the computer, you're just going to have to suffer, because the third graders here solved out how to use the super duper all-purpose measuring device to find length and width and height and volume and mass. And so here is the sound that I like to hear. Computer, you might as well just be quiet.
Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission, to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
Now that's what I talk about, good space music, computer. I'll tell you, computer, you've been pretty good helping us with our super duper all-purpose measuring device. But I'll tell you, sometimes, sometimes it's good to talk with my own computer, which I call, I have a computer, my phone right here is calling me. Can you hear that? Very strange. Computer, I'm sorry, these kids are good. I'll tell you what, I know what I'm going to do. I got this figured out. Ready? Here we go. Computer, are third grade students the best students in the world for science?
I found 4 computer stores. 3 of them are fairly close to you.
No, computer, I don't want computer stores. Would you listen for once? Computer, aren't third graders the best scientists in the world?
I found 4 computer stores. 3 of them are fairly close to you.
I don't
I've
care
sorted
about
them by rating.
No, I don't care about that. Computer, stop.
Here's what I found on the web.
I don't want the web. Here's what I want, computer. I'm going to ask you this one more time. Computer, are third graders the best scientists in the world?
I found 4 computer stores. 3 of them are fairly close to you.
Well,
I've sorted them by rating.
I don't care. I'll tell you what, boys and girls, sometimes computers help us and sometimes they don't. It's a good thing, though, that we have our super duper all-purpose measuring device. Well, good luck. And computer, do you love science? Computer? Computer, do you love science like we love science?
I'd rather not say.
Oh, brother. Good luck, boys and girls.
Space, the final frontier.